Okay, thanks, Josh. Hi, good morning, good afternoon, good evening, etc. This is a discussion about securing the container supply chain. Um, and you've noticed that I have specifically called out containers because they have some interesting quirks about them that makes them extra special when we're talking about container supply chain or software supply chain security. So I think everyone knows about the SolarWinds supply chain compromise. The way the compromise happened is that the the attack vector was the publishing infrastructure for the SolarWinds um, update system, which they call Orion. Um, the uh, the thing is that uh, supply chain compromises are not new. They've been happening for a while, and they've actually been growing. Um, CNCF SIG-Security supply chain working group has cataloged a number of supply chain attacks starting from 2003, and a good amount of them are attacking either the dev tooling or the publishing infrastructure. Um, Google Cloud has a good paper out, a white paper out, talking about the stages in the supply chain which one has to focus on and secure. Now, the interesting thing about all of the proposals that have come out is that they've been focusing on securing the source code and beyond, but not much focus is given to the first thing, which is securing the baseline. And the reason for that is that the baseline is different for different ecosystems. So here's a list of baselines. You have bare metal, which is the baseline for firmware, VMs, the baseline for um, cloud infrastructure, dev environments, containers, which seem to be the baseline for everything. Serverless environments, the baseline for functions as a service, networks as the baseline for traffic. And the reason why we're focusing on containers is because they happen to be the baseline for just about everything from um, build systems to cloud infrastructures to dev environments uh, to network traffic to like the modern applications, all of the things. So that's what this discussion is focused on. Um, so there are many quirks about building containers that hold some uh, that pose some difficulties in securing their supply chain. I don't know if anyone's been in the BillKit talk. I had asked so many questions about BillKit's building infrastructure, and this is specifically for trying to figure out, where um, what the build infrastructure looks like, so someone can help secure that kind of infrastructure. Um, so the reason why containers are problematic is that it is actually the artifact of many supply chains. So not just the base OS, but it's also the system dependencies for the application itself, and the application's transitive dependencies. So, and then on top of that, there are multi-stage builds that use build images and deploy images. And even though there's a lot of best practices out there that say the deploy image has to be as small as possible, the same consideration is not given for the build image. Um, Update management is interesting in the container world because to update a container, you just have to build a new one, but there's no information on what exactly got updated, where it got updated, who sent the update, um, and all of those little bits and pieces that make up an update, there isn't really much information with regards to that beyond, the digest of the container image changed. The signing and the verification of upstream containers is based on upstream providers. So you are reliant on the upstream providers to have signed their images. And all the middle people along the line should have done the same thing. There isn't currently any way of recording that information. And then build systems are dependent on containers. So there are many build systems out there that pull in existing containers to use as builds. Are these existing containers updated? Are they maintained? Who owns them? Who creates them? These are all things that are taken for granted. There's a situation where project source code contains make files that use that invoke Docker to go and build a deployment container. This is obscured from anyone who is using the open source project to deploy SaaS or products. So it's very difficult to figure out, what exactly gets used in the build system. And the last thing is containers are really easy to create, but they're very hard to audit. So this is why I had proposed having a discussions on this. Okay, I'll go to tools and their gaps. Container scanners exist. There's Luis is the maintainer of Claire. Luis, am I right?
Yep, that's correct.
I am the maintainer of Tern. So both tools kind of can figure out what's inside an existing container, but they are heavily reliant on upstream or proprietary databases. So it's also very difficult to understand what exactly went into a build from a container that uses multi-stage builds, because it's a shrunk down container. It doesn't really give information about what exactly happened to produce that container. There are lots of signing and verification tools that are out there, but we are still dealing with questions about how do we trace back the signing and verification chain to the beginning of the source code. Also, basically, signing is a hard thing. It's not like everyone in the ecosystem knows how to sign an artifact. Then there's managing updates. Right now, the only tool that I know of is Cloud Native Build Packs that manages updates really well, because they have a tool called Pack Rebase. And Pack Rebase will rebase container layers on top of a layer that has recently been updated. So I think that's pretty cool. The downside of it is that you have to trust the suppliers of the build packs to be able to update. And sometimes you're dealing with open source, maintainers come and go. It's not really clear, whether they follow all of the best practices to keep track of updates. Okay, and with that, I am going to seed discussions, and I'm also going to ask Steve Lasker to talk a little about the signing and the verification stuff, because that's the first question that comes up. Okay, I'm gonna stop here and take notes.
Well, hey
Steve?
folks. So it's definitely been an interesting space. We have this concept of content that we can bring into our environments, and it's not just packages. It's like entire platforms, entire shims of the OS. And I think we've all seen some learned evolution that the internet is great to acquire content, but let's not depend on the internet to pull our content, for instance, directly from Docker Hub or NVIDIA or Quay or any of the public registries, is to bring them into our environment and then we run them there. But of course, if you're moving content from one environment to the next, and then the next to the next, as you go from dev staging to production, how do you know if anything's changed along the way? So that's definitely been a challenge on what is this industry solution. But as Nisha talked about it's not just the container image itself. Like we're working on a way to sign an image, and we'll definitely talk more detail about it. But and when you sign it, it can move across registries, and the signatures will move with it. Like we think that's just it has to be a starter, right? You have to start there. I know have some integrity around the content that moves. But as Nisha mentioned, for certain languages and runtimes where you're taking a binary output of the build step, it's great that I know that thing moved, but what went into it? What was the packages that went into it? What was the compiler options that were set on it? In fact, the SolarWinds exploit was a flipping of a bit on the compiler that opened up a door. So it's really important for us to not only sign the images as they move across registries and know that still integrity is still there, but what's in it? And there's this, bill of materials that people are talking about, and Nisha's been driving some stuff there too. So we want to take the image, the content, and we want to take an Sbomb that comes with it and say that the Sbomb is also signed. So when it's got its integrity. The fun is if you ever watched all the old Star Trek or I guess it's all Star Trek movies, the TV shows rather. The first time that they get exploited, that somebody does something evil, and then the next thing they do is they delete the log entry, so nobody knows the evil thing was done. So it's really important to have the Sbomb being that log and all of that have some integrity to it as well. So I don't know if that covered what you were thinking about there, Nisha.
Yeah, it does. So I want to ask, is signing and verification at the most basic level hard right now? I mean, or is that just something that I picked up from the internet and I'm repeating over here? It's hard for me. There's it seems to me that the de facto way of signing is using GPG. GPG may not be that intuitive to folks who are building and deploying source code or artifacts. What do folks think about that?
I think it can be kind of, I feel like signing in general, the base concept is, if you look at the really, what it boils down to, the cryptographic concepts are, something that are familiar to everyone. But I think that there are a lot of like nuances that need to be noted of. For example, a lot of traditional signatures, like you mentioned, GPG signatures. There are some attacks within the software supply chain that may not be prevented. For example, you can repeat a signature for all vulnerability. How do you manage that? And I think like a lot of different systems have different ways to manage it. With images, we have the image tags, which has its set of pros and cons. And also everyone signs, I think this is kind of jumping ahead to your second question, but I think everyone has like a different intention of signing, and kind of having the software bill of materials, creating a standard around it that, Steve has talked about, is really one way to get everyone to this, because it's in the end, it becomes a collective effort.
And the signing is interesting too, because we've watched different cloud providers and software vendors come up with solutions, and like Google's got some pretty interesting stuff with their binary authorization. Docker tried with Docker Content Trust, and it just, because it doesn't move, there's a bunch of problems related to it. But the thing that we kind of realized, because Microsoft's a software company, not just the cloud, we certainly want a secure solution for Azure, right? That's a no-brainer. But we also need to recognize that our solution needs to be for the Microsoft software that we ship on our Microsoft Container Registry, MCR, which we make good business from people running our software in other clouds and on-prem and other locations. So we need to make sure that the software that we signed as Microsoft, not Azure, is capable of being validated on all these other clouds and other environments. So I think that's why you see us kind of driving a little bit more of a different approach, is that we're selfishly driving a consistent standard across the industry, because we need that standard to work across all clouds. And yeah, it's a good excuse to do it as an open source effort, but the reality is we know the industry as a whole needs a better secure supply chain. And if everybody's running their own security sandbox, as soon as you move it from one place to the next, if there's no commonality around how things are signed and what is the definition of an Sbomb, then that, anybody that's playing that phone tag game, as soon as you're converting something from one to something else, that's your point of vulnerability, intentional or not, right? There's a potential for change and bad things to happen. So we think it's really important to have a signing standard, a consistent standard through registries that things can move. And signing shouldn't just be for container images. It should be for the Sbomb. It should be for expanded things like some of the stuff the Nidus project is doing, and we're doing with Teleport and other things. There has to be some standards. There has to be consistency. If you went to every website and had a different SSL model, a different model for SSL, obviously that doesn't work.
And
so here's the sticking point for that, Steve. It's that most of the software that companies like Microsoft may or may not use, at least what I've seen with general product organizations, is that 99% of their software is open source. So it's almost like you don't want just the organizations to sign their artifacts. You want like Joe developer to sign
Absolutely.
their artifacts.
I think that's what
too.
You're seeing with what we're doing with Notary V2, is not only can, we have this goofy examples of Wabbit Networks and Acme Rockets as just some fun company names, but they're intended as small companies that need a solution. And we also want to make sure that whether they're consuming software from large companies, some of the larger software vendors that put things out in the container space, like NVIDIA, Red Hat, Microsoft, and trying to think of Oracle, some others, that as companies bring that content into their environment, they should be able to stamp it with another signature that says it's great that Microsoft or NVIDIA thought this was great, but does it work for my environment? And so they could add their own signature. Or that two-person shop that is just trying to build software and maybe even ship it for others to consume, they should also be able to sign that content and be verifiable. So this is, absolutely geared towards the large companies, where they can have the trust of that, that somebody would expect from a large company. But the small company should be able to get that same capability as well. And I think that's what you're seeing in the tension that we have in some of these discussions is super secure is awesome, but if it's so secure and not usable, people are just going to prop the door open and the security's out the window. So you have to balance that security and usability, and when usability is meant to be for the end users, but also the small to large companies.
The general question. Yeah, as a general question.
Go ahead.
How far do you think we'll get without really bundling signing into the tooling that we're using on an everyday basis, right? Because when you have, like to your point, Nisha, when you're saying, I'm a application developer who's trying to create a product, signing is the last thing they're thinking about, not on purpose, right? But it's just, hey, it's not in the if we're looking at like web tech development, it's not a big factor. So there are these great efforts with Notary and such, but are we missing the goal by not looking at embedding these into our everyday tools to begin with? Because it's the only way we'll get a chain.
Yeah, agree. I'll try to repeat it. So Louis, we're not really hearing you. I'm not sure if you got the wrong mic set up, but it's at a long distance. So I think to summarize what Louis was saying is it's great that we have these signing things that you see some of the stuff working on, but it really needs to be integrated into the supply chain, the tools that people use on an average day. There's a couple things that developers never get to. It's tests, signing, reporting, right? There's this bunch of things that we know are important, and we just don't seem to get to them. So they just need to be made easier. Doesn't mean they're not important. We just need to make them easier. I completely agree. So using physical keys, when you go around, we're always going, where's my keys? Where's my keys? It's a problem, right? We deal with that, so we try to find our keys. We need to make it more like using thumbs to get in and out of a place, or other things that are inherent in the system. We really make that usability there. What I hope you're seeing with the tooling and some of the stuff we're doing, at least in the Notary V2 space, is trying to demonstrate how the pieces can be used individually, but there are libraries that when you do Docker build, Docker push, it should just work. You'll have to tell it where your key is, but you shouldn't have to do all these extra steps. It's a balance that we sometimes struggle with when we do these demos. I want to show the simplicity of what we're shooting for, but if somebody is using BillKit instead of Docker or some other build packs or something, that it should be just as easy. They just have to pull those libraries in. We have this thing called ORAS, and we have this NV2 stuff. There will be libraries that people can pull into their experience. In fact, if you look at what we did with OCI Artifacts, part of what made it, I believe what made it very successful is not that we just defined this, the spec to how do you do it, but we provided the ORAS library for a bunch of these artifact authors to just pull in and make it work. So there's like 10 people that know how to use ORAS, probably a little bit more, but then there's millions of people that are using the tools that happen to use things like ORAS to push things in. So what I'm hoping you'll see is, as we get this done and we find that right balance, that you'll see BillKit and Containerd and, name your cool project that needs to have signing, not just on the build and push, but on the consume. Like our measure of success should be that just works. And we should be putting out the libraries that people need to enable those really integrated experiences.
Is my mic a little bit better now?
Yes.
Okay, great. Okay,
I can hear you.
Yeah, I was just gonna add on what Steve was saying. Also, I think there's a lot of onus on the key management side that's put on the user now, and key management is not something that's I would say, to be very secure, it's not the most usable thing. But I think like a couple of years back, I was at the event and they were giving out Ubi keys, right? I think that's a good start. Having a more consumable key ownership and being able to do that better will definitely help that.
Something I'm a little bit curious about too, there is no specification for container building, right? Like we have OCI specifications for like distribution, but we don't really have a specification for building. And that's correct, right? It just fact checked me. So that's the case, it becomes a little bit harder to even build this tooling into, or build the signing into our tooling, because there's no specified way of actually doing the building itself.
But do you need to? Like, if different people build a house this, different ways, but the end result conforms to a spec, right? There's building standards. Yes. So if I think of the image spec,
there, right?
Well, but the image spec is there on what, it doesn't matter how you get there. Like build packs, to me, build stars. The build pack is an interesting idea because they figured out how to do this binary level compatibility thing, which container builds don't generally do because of the overlay file system. So they can do patching more easier because there's this BCP. I forget what they called it. Anyway, so I think to some extent it's creates a lot more freedom for innovation, because we're not trying to dictate how the sausage gets made, just as long as when it's done, it has to wind up in this form. And I think over time, what you'll see is, there'll probably be a couple of different Sbomb formats. I'd be happy if we just had one that people were comfortable with. And there are a bunch of efforts evolving. So I'm confident that's coming together. But, when I look at an image, I'm hoping I will get an Sbomb, and that will be, some trustworthy thing. And then again, how you assemble it, how it gets to the end result, I'm not sure if it matters too much, as long as the end result includes these core elements. It must be signed. It should have an Sbomb, which also must be signed, right? So I think there's a couple of things that we should figure out, and what are the end results? Okay, what are the standards for what the result should be, not how you get there.
Yeah, I think that's very fair.
So with regards to the spec, I think what happens is that folks usually lean on Dockerfile best practices right now, and the issue here is that that's the first place that people go to look at. Okay, I know how it's now easy for me to build a container image. How do I make sure I build the right one? And that's kind of why the build pack, Cloud Native Build Packs has the build spec. The build specification kind of ensures that if you are building a container image, then you're building it so that it can be traced back and updated and all of those things. The trouble with the build specification is that in order to make your app work in an environment, you have to have a combination of system dependencies and application dependencies, and maybe like the one-off that you download from the internet. Folks don't necessarily keep track of the thing, like what they're doing. So this is actually a focus of my work right now, is to how to make Sbomb generation intrinsic to container building. But maybe there's a way of making signing intrinsic to container building as well. Maybe, I mean, so in the way that I'm thinking, that if during your container build you have to download a binary from some project on GitHub, you can validate the signature of that binary, or you can say this binary was not validated, this binary was not signed, but it was downloaded from here. I have made, this is my contribution to a previous container image, and this is the Sbomb for that contribution. Is there a way of doing that right now?
Yeah, auditing external dependencies.
Take that as a no.
It's a tough problem. I mean, it's definitely nothing that I know of internal tools that do it. And if you really think about it, it would maybe entail some kind of like proxy mechanism to even see where you're going out to. And maybe not, it could be done within the tooling itself, but not that I'm aware of. But I do think that it is a necessity, right? Once you start pulling in external items, external artifacts, build can, like, reproducibility in the build system alone goes out the window, right? You could be pulling a different artifact every time you do the build. So getting any kind of reproducible build.
Does anyone know if BillKit has that kind of auditing? That was a question I asked.
I'm not familiar with the BillKit details, but I know at least when you use the Docker CLI and you enable Docker Content Trust, it's going to also it does some out of the box best practices in terms of, okay, it's gonna kind of save the hash and things like that, making sure that everything's best effort reproducible. But there's too many things in it, just in the way that and it's not just containers, right? Everything has a different pipeline, and it's something that it's a big problem because it's very difficult to audit. Having a standardized Sbomb that Steve and others are working on is going to be the first step, and then hopefully all the tooling will implement that. And hopefully, I know there is some work that's going on in terms of also on the build tools, like the software factory side of things, to be able to create a secure environment and also to kind of standardize on some of the tooling in the build environment as well.
If you're okay with some questions from the chat, Silvano brought up a related question to this, which is he was asking whether or not Claire and Tern
Go ahead.
only looked at bill of materials in terms of actual packaged binaries, as opposed to binaries that might come into the container without packaging metadata.
Or like what was used to build the binaries that went in kind of the multi-stage build problem.
Tern can do that, but only with a provided Docker file. It cannot do that. I mean, I don't even know how one could do that if it was just the output of a Docker build and you have like a stripped down container image with no metadata and no indication about where it came from.
As far as Claire goes, I mean, we basically do static analysis on layers. So we're confined to what we can find in the layers, which also means that we're mostly looking for package metadata to understand what's inside. There has been at least a conversation about binary analysis. I talked a little bit in the chat about how that can fall apart or how that can actually just produce a ton of false positives. Anyone that has tried to do it, I think, has experienced that. But we do some, we'll search the layers extensively for any kind of metadata we can find or file system assets in terms of language packages. But the multi-stage build is an interesting problem, and we do not have a solution for that today. But it is an interesting one that I think we should give a little bit of thought to.
So the way that Tern analyzes the multi-stage Docker files is that it will actually create individual Docker files for each of the stages, almost reverse engineering the Docker file, the multi-stage Docker build paradigm. And from there, it'll gather all the metadata for each of the stages. It doesn't really have any ability to say, like, this container is the build stage for this other container. It's almost like you have to figure that out by yourself from the report that it generates. Yeah, and it really depends upon what the build system is. So Tern tries to guess based on a number of things. Certain files that are in the file system, anything that's in the history, anything that is in the config file, like labels and environment variables. So, I mean, it's best effort. And it works reasonably well for certain ecosystems. Like it works well for Debian because, you know, Debian is like that community is really good about build reproducibility and software bill of materials and updates and all of that stuff. So it's pretty straightforward for Debian. It's not that straightforward for any other type of image. And once you get to the level of language package managers, it kind of breaks down after that. So yeah, it is based on the ecosystem, and it's kind of why I started on this path, which is okay, the scanner is not able to give me all the information I need. How can I get that information? And the only way that I've been able to do it is hacking container
kind
builds.
of touches on the end result kind of problem and having some trust through the entire stream, right? The hacking a compiler was an interesting thing, right? So it's not just what went into the content. It's not just the package list that's in it, but what was in the package list that built the binary that, you know, was a self-contained binary that went into the thing. What's in that base image and how was it compiled? So that's why I think we're going to see this evolve over time. I think it's not going to really be a bottoms up evolvement, so to speak, but more of a tops down. Is we'll see what was at the surface, what's in the build that I put into it. I don't really know what was underneath it. Over time, hopefully those base images will say, here's how I got my stuff into it, and they'll provide an Sbomb. And it says that, but we don't necessarily know what went in before that. So there's just, and there'll be some that'll come up from the bottom up as well. But there's this concept of a chained Sbomb where I can say, for each step along the supply chain, what was the bill of materials for that thing? When you buy a car, right, you can see what tires were on it and the seats and so forth. And we've learned that airbags are important to know who made the airbag that went into that car. But what were the components that went into the airbag? What were the components? Like there's an engine that was dropped in. What was the components that went in the engine? What were the components that went into the alternator? Or the battery pack for electric cars or whatever. So there's everybody. The only way we're making productive, moving fast in the software supply industry is we're leveraging the work of others. But what went into the work of others? So we're going to need to be able to inspect and trust elements from where they came and understand what the content went into it and how that content was created. That's why I kind of like the compiler flags as a really interesting problem of it's not just what went into it, but what were the configurations that were set when that thing was built.
Hey, Steve, you brought up chained Sbombs. Are there such things as chained signatures too?
We haven't yet. There's. I think that'll be something that'll have to evolve a little bit more. The thought that we've been having thus far is it's great that like the Wabbit Networks goes to Docker Hub and goes into Acme Rockets. I don't know who Wabbit Networks is. It's a small company, so I don't really trust them. But if it goes into Docker and Docker has a certification model, whatever that means, totally hand waving. But let's say a company trusts Docker that they take a subset of this vast majority of content that's up there, they do some certification, and they say this is trustworthy, just like the apps on our phone to some extent. Is it that Docker signed the Wabbit Network signature, or that Docker's got a process that when they brought it in, they know the content came from Wabbit Networks, and then they sign that content? Chain signatures is, now you've got to walk that chain. I don't want to recreate a whole blockchain kind of thing. So I don't know if we need that yet. So we haven't done that. We've definitely done like the new OCI artifact approach allows the linkage. So there is this chaining that could happen. So by definition, sure, a signature can sign another signature. I'm not sure how useful that is yet.
Yeah, I think just with being able to sign some metadata on how you came about with the signature, I think seems to solve most of the use cases today.
That seems to make sense. Is try to keep up with all the questions because there's a lot of good ones there. I'll go see if I can find.
Read off questions if you're ready to take them. To have a So the first one we actually got off of was from Carlos, who was basically bringing in, this is sort of a big picture question, right? Which is, we had ways to distribute software before. We had some way to secure those supply chains, presumably. So what happened with containers? And is this primarily a lack of tools or primarily a lack of education? I paraphrased you, Carlos, but I think that was what you were asking.
I can answer that somewhat. So I don't think developers have a good idea of what package management entails. So yes, there are tools existing to to secure pipelines. This is what the embedded community has been doing for years, and they have it down. In fact, a colleague of mine, Joshua Locke, and I had presented at a KubeCon about using distro tools to build container images, which allows us, which actually provides us um, all of the details that we need, such as the Sbomb, knowing exactly where the source code came from, and having like a build graph that is traceable. Containers are just easy to make because you can like put whatever you want in it. And so I think that kind of generated so much of adoption that nobody really bothered with all of the other stuff. In fact, when I started asking people about this 3 or 4 years ago, the response I got is, why bother? Why do you care about this? 3 years ago, we didn't have the SolarWind attack. So I guess now people are paying attention. I don't know if that answers your question, Carlos.
Back to him if it doesn't. Next question, and again, I'm going to keep paraphrasing because the discussion kind of moved on from the point where you made this comment. Cesar was actually asking about mandating rootless builds. And he was asking specifically about Podman and Builda, but I think it's a more interesting question in, would we consider mandating rootless builds to actually be a secure supply chain enhancement?
Rootless builds.
Yeah, it's Brendan.
Oh, go ahead,
I
Steve,
want to say
or
this,
whoever.
like
I can't
rootless
see.
builds, I think is kind of a nice enhancement to kind of strengthen the way of building things. But I think really it boils down to the security model of your build infrastructure. And if you're running all your builds within a VM, for example, then having a rootless build will be kind of another line of defense, but it's not essential. It's a nice to have. I would say depending on your requirements of trust. If you ask your enterprise developer versus someone in the financial industry, you get two different answers.
I think it's a good question also, because I think one of the things I see often is this kind of, not confusion, but conflating between security via isolation and image provenance. So the things that we're really touching upon here is understanding the entire chain. And a lot of times this conversation gets a little bit confused with like isolation, which is a great thing to achieve and is definitely necessary, but kind of, if you're only paying attention to that, which I think was the case before SolarWinds, or before this topics became much more focused, all the emphasis was put into isolation. And I think a lot of work was done there, right? You had like Google VM containers, and you had encapsulating and protecting from the root machines. But that's not exactly the crux of the issue when it comes to actually understanding the supply chain.
I think there's, look, rootless is certainly an interesting aspect. I think the ephemeral clients, what I mean by that is, every time a build is done, it's going to a stateless, not stateless, a clean state, a known clean state machine. So that's part one, right? SolarWinds was partly, and everybody's piling on SolarWinds because it's the latest, but it's a good example of a bunch of things that hit us blindside. Because if we all should recognize this. Scanning for the vulnerabilities we know about is table stakes. It's the things that we haven't thought of, and the dangers when smart people who are, pulled into the dark side and take advantage of all the things that we all know are possible. Let's just hope nobody does. So there's a couple of safety things that you can do. One, have a ephemeral client that that, I saw this mention of distroless. So like there's a clean state that must get used every time a build is done, including runs in some cases. The other is creating an air gap environment around your build, right? Any build can be fine, rootless or, ephemeral client, and then somebody curls something in from the internet, and who knows where that came from, right? And in most cases, humans are just trying to do things to get stuff done. They're doing things, not malintentioned. So if you put these safety nets on things, these boundaries that says you cannot go out to the internet. The only thing you can install into your builds is from these package managers that are private package managers that company is stamped as certified in some way. Now, the content got into those from the internet, from public places, but they were also validated before they went into there. So that's, ephemeral clients, completely air-gapped environment, so that your builds happen in isolation only from trusted sources is key. Because then, for instance, the SolarWinds exploit thing, first of all, if they got code on it, if that thing's in an air-gapped environment and can't reach out to the evil person in the first place, then great, they got something into your environment, but as the data tries to stream out, it just hits the firewall, it doesn't go anywhere. So you have to kind of think of those basic pieces in place as part of your secure environment.
Just to add on the attestation bit as well, this is something that I work a bit more closely with. It's every time we talk about it, we say it's trusted, but trusted but maybe vulnerable, right? You can measure exactly what you're doing, but if exactly what you're doing contains vulnerabilities or has been tampered with, it's as good as the checks that you're doing.
Okay. So another tooling question from Spindell, not sure which. What about CI systems? What CI systems actually validate, say, signatures as part of doing an integration?
Like what products have already integrated the stuff that we haven't finished building?
Yeah, exactly.
Yeah, I don't look, there's lots of good tools out there. Don't get me wrong. I don't think that we've hit a standard yet. So I think any CI system that can be called a CI system can run tools, then they should be able to run these the various verification tools that make sense to them for their environment for now. We need to up the bar and create that standard that people can say, here's the baseline for what you should do, and we can do better from that, but here's at least what you should do. I don't actually think we're there yet. We're trying to get there. There's some smart people. There's some big companies that have vested interest into this. So I'm confident that we'll get there. I'm hoping we'll actually have some semblance of a baseline from an Sbomb, from a signing solution this year in 2021, because what better way to kind of end 2020 is with some of these things better. But I think you have to look at any of the CI systems or even the runtime systems, right? As saying, do they have the ability to run tooling to do whatever the latest and greatest is at that time? And I think of this in some of the serverless environments as well. We get awfully focused on doing security around Kubernetes. Well, anybody can run security on Kubernetes because you run a sidecar and you give it some privileged access to watch network traffic, and you should be good. Well, that should be good. You have the ability to be good. what do we do around some of these closed platforms that we as cloud providers offer? Like, what is our secure solution there? Because there are these multi-tenant PaaS services that we need to provide better hooks so that we can have a competitive security solutions put in place there.
So I don't think that off-the-shelf CI systems actually have any of these verifications in place. I'm thinking about Jenkins or Knative. Knative particularly comes to mind because their workload is essentially a container image. Whether they have they curate their own build container images and have systems to verify those container images to make sure that they are in the state that they expect them to be. I don't know if they have all of those checks. As for the ones like GitHub Actions or Circle CI, I'm not sure.
One other thing, going back to signing, Sean actually was asking about verifying that the signing authority is who they say they are, in addition to verifying the signature, and pointing out that that's a major problem, and asking what solutions there are for that.
Yeah, this has been a pretty well-known problem, and ironically was one of the places where the usability went too far. There was this trust on first use model, which means if the bad person got the key in first, then they just own your system from then on because they were the first use. Ephemeral clients help that because there's never, you have a clean environment every time. Key management is still a big part of at least the Notary V2 workflow that we're working on to make sure we get that secure place, and it has to come from separate sources. So you have like two independent, the two key submarine nuclear solution kind of thing. And key revocation and whatever that definition has to be a core part of that. I want to be able to get the key from the entity that authored the software, whatever that means, the public key, and I need to be able to say that at any point, is that public key still valid, even though it didn't expire yet, and I don't make me check that it expired every 5 minutes because that doesn't scale, and let me run it into an air-gapped environment, which is not just nuclear submarines and oil platforms. It's customers trying to take what they created as a private environment on-prem, and they want to run a private environment on the public cloud. So air-gapped is every customer, well, not every customer, most customers want air-gapped because that's the level of services that we should provide. And that key movement needs to be able to, and key revocation needs to be able to work across those separate environments. So completely agree that you should be able to know who trust that the key came from the authority, and know when something happens, not if, when something happens and that key is exploited, that you have a way to know that it was exploited. I like to use the passport do not fly list examples when you go into the airport, but as somewhat of an example of that.
What about this new project?
It's a new name. It's called SixStar now, I think.
Recore, which is
yeah. These things change always.
Oh, is
yeah,
it?
so
Is
that
it
project's interesting because it kind of it's focused on the transparency part of this, right? It's essentially blockchain without blockchain. Except in this case, we trust a certain couple of vendors or parties to maintain the trust of that star. So I mean, I think that's a good step in the direction. It kind of brings us closer to a more certificate, with certificate authorities and web browsers. It kind of brings it closer to that level of usability, and hopefully, this will kind of help the standardization as well.
Brandon, you want to also plug SIG-Security?
Yeah, I'm going to do a shameless plug for SIG-Security. We have a software supply chain working group that's working on the supply chain white paper right now. I'm going to repost the issue in the chat again. But yeah, this is something that we're working on. It's currently in draft. The draft is public, so you can go take a look at it. A couple of folks there, Jonathan Meadows is driving that effort. So do take a look, and we are always looking for contributors.
And just to be clear, that's CNCF SIG-Security, not Kubernetes SIG-Security.
That is true. We have an email discussion about that.
Yeah. Okay. Any?
Yeah, I was going to add that the In-toto platform has this kind of verification model where there are a number of roles that have artifacts assigned to them, so they can only sign that kind of artifact. You can do delegations of the keys and have expiry dates on the keys, I believe. So, I mean, it seems to me that there's people know what to do. It's just like really difficult to start doing it because there isn't anything out there that does all of these things like in a seamless way.
The In-toto project is a pretty interesting one, and it's the only one that I've seen that is really trying to do an end-to-end solution where attestations from the root of the chain all the way through. Definitely, we've been looking into that to get Claire's results signed. We should be in talks with them, but I think you're kind of in the same area that I'm in, and getting those results signed and getting into their chain just is beneficial for us. So it's definitely a cool project. I would check it out if you're not aware of it.
Cool. And we are at time, so let's have a quick round of last thoughts. I'll start, Brandon.
I think we had a great discussion. I think we agreed that there's a lot to do here as an industry, and I think it's a collaborative effort, and we have to work together in the community to make this happen.
Okay, Steve.
I agree. I mean, I think, as I mentioned, no one company can do this because in this world of internet and open source and collaboration, that content needs to move, and we need to be able to trust the content we consume from all different sources. There's no good baseline yet. I think we need to establish that baseline, and then we'll continue to iterate and make it better. So it's definitely an evolving space. I think we're sharing more content than ever before. I think that's one of the differences between on the signing, what's changed around signing before. So I think that's a big piece of it. And lastly, I've been really impressed with this conference as a whole. I haven't had too many conferences that have grabbed my attention for so long, for all the great speakers and content that's got pulled together. And thanks to Nisha for pulling us in and organizing this event. And Josh, to you, he's, you might see him as the person moderating some of these, but he, at least from my perspective, organized a lot of what came together. So thank you to Josh.
Well, welcome. Luis?
Yeah, I just want to say thanks to everyone, especially Nisha, for inviting me to this and giving me the information about some exciting projects that are coming to fruition. But yeah, I mean, I'm pretty excited. Steve, I think you made a really good point about how this is actually going to unfold, where each individual is going to deal with their own Sbombs, their own necessities for signing, and then the layer underneath is going to develop a solution, and then you're going to chain that. So I do see that happening. I think, and I'm excited to see that, and I do think that there will be rather big explosions happening in various portions of these chained artifacts that I look forward to at least being part of. With Claire itself and any other projects that we take on. So yeah, I think it's a really cool time to be involved with security software and supply chain particularly, and I'm excited to see the projects that come up and manifest. And thanks for everyone. For the questions, they were great, and thanks for everyone on the panel.
Okay, and so want to wrap it up, Nisha?
Yeah, sure. Please help. We all know that this needs to be fixed, so it would be great if there were resources that were put towards this. It's not a very glamorous thing to do. It's like not shiny, but it is necessary. And it would be nice if like folks actually put some resources towards building some solutions.
Effort. We need the community to help. This isn't just a couple of people. If you have some opinion on what you think it should look like, then contribute. We can use the help.